Hello everyone, I am Dr. Dhirendra Singh Kshatri, a professor in the Department of Physics at Sri Shankaracharya Institute of Professional Management and Technology, Raipur. Today we are going to discuss the topic of surface tension as part of the course on fundamentals of engineering physics. Today we will cover introduction on surface tension, definition and explanation under which molecular interactions, cohesive and adhesive forces, cohesive versus adhesive forces, surface energy, mathematical expression, examples in daily life will be described, and then we will discuss about measurement of surface tension, factors affecting surface tension in engineering, innovations and research, applications in daily life, and summary will be the conclusion remark. Surface tension can be introduced as it is a fascinating and fundamental property of liquids playing a crucial role in various natural and industrial processes. This property can be observed in phenomena such as water droplets forming beads on a surface, insects walking on water, and the behavior of bubbles and capillary action, which can be clearly seen from the figures. Understanding surface tension not only provides insights into the behavior of liquids, but also has practical applications in field ranging from engineering and medicine to everyday household activities. In this introduction, we will explore the basic principle of surface tension, its causes and its observable effects in nature and technology. It can be defined as surface tension is a physical property of liquids that results from a cohesive forces between molecules at the surface. These forces create a skin film on the liquid's surface that resists external force. On the basis of molecular interactions, we can understand that molecules within a liquid are attracted to each other by cohesive forces, and molecules at the surface experience an imbalance of these forces as they are not surrounded by similar molecules on all sides. This imbalance causes the surface molecules to be pulled inward, creating a tension that minimizes the surface area. This can be observed in the figure given here. Cohesive forces can be understood on the facts that molecules in a liquid are attracted to each other by intermolecular forces. Inside the liquid, each molecule is pulled equally in all directions by neighboring molecules, resulting in a net force is 0. At the surface, molecules are pulled inward by other liquid molecules, but not outward, since there are no liquid molecules above the surface. This creates a net inward force leading to surface tension. On the other hand, adhesive forces are the forces of attraction between the liquid molecules and the different materials, such as container wall. When adhesive forces are weaker than cohesive forces, and the liquids tends to form droplets. These forces can be seen from the given figure also. When cohesive forces dominate, the liquid forms droplets. When adhesive forces dominate, the liquid spreads out. Surface tension can also be described in terms of surface energy. The energy required to increase the surface area of a liquid by a unit amount. Higher surface tension corresponds to a greater surface energy. Now, we will show mathematical expression of surface tension, which is quantified as the force per unit length, which is given by a formula which is gamma equal F by L, where F is a force and L is a unit length. Unit of the surface tension is given by Newton per meter, and dimension we can calculate well with the help of gamma equal F by L. We know well that the dimensional formula of force is ml t power minus 2, and the dimensional formula of length is capital L, which upon solving we are getting mt power minus 2. So, the dimensional formula of the surface tension is in square bracket gamma is there is equal to in the square bracket mt power minus 2, because dimensional formula is always represented in the square bracket. Now, we need to understand the angle of contact, which is formed at the tangent point between the liquid surface and the solid surface at the point of contact. Based on this, three cases arises. First, when angle is acute, that is theta less than 90 degree, the liquid wets the surface well, spreading out and forming a flattened meniscus like water on glass, where the water spreads out due to strong adhesive forces. Second, when it is right angle, that is theta is equal to 90 degree, the liquid neither spreads nor contracts, but forms a straight line contact with the surface, such as mercury on a glass plate, where the forces of adhesion and cohesion are balanced. Third, when obtuse angle is formed, that is theta is greater than 90 degree, the liquid does not wet the surface effectively, forming a droplet with minimal contact area, like water on a wax surface, where the water beats up due to a weak adhesive forces. Some examples in daily life can be observed as water droplets, we know well about that, and soap bubbles, it is being observed in daily life. Next one is capillary actions around us. Surface tension is measured by some practical methods being briefly described here. One is capillary rise method, based on the principle that surface tension causes a liquid to rise or fall in capillary tube. You can see it in the figure. Procedure of the method is a thin capillary tube is placed vertically into the liquid. The height h to which liquid rises or falls in the liquid is measured, and the surface tension is calculated using the formula gamma is equal to h rho q r divided by 2, where h is the height to which the liquid rises or falls in the tube, rho is the density of the liquid, and g is acceleration due to gravity, and r is the radius of the capillary tube. Coming to another method, which is drop weight or drop volume method, based on the principle that the weight or volume of a drop of liquid detaching from a nozzle is related to surface tension. Procedure followed is liquid is allowed to form drops at the tip of the tube or nozzle. The weight or volume of each drop is measured and surface tension is calculated using the formula gamma is equal to mg upon 2 pi r, where m is mass of the drop, g is acceleration due to gravity, and r is the radius of the nozzle. Next is Wilhelmy plate method, based on the fact that the force exerted by surface tension on a thin plate dipped vertically into the liquid is measured. Procedure of the method is a thin flat plate usually made up of a platinum is suspended and partially immersed in the liquid. The force created on the plate due to surface tension is measured. Surface tension is calculated using the formula gamma is equal to F by P, where F is force exerted on the plate due to surface tension and P perimeter of the plate in contact with the liquid. Next one is Dunois ring method, in which the force required to detach a ring from a surface of the liquid is measured. Procedure is a thin circular ring is placed on the surface of the liquid. The ring is gradually lifted and the force needed to detach the ring from the liquid is measured. Surface tension is calculated using formula gamma is equal to F by 4 pi r, where F is force required to detach the ring and r is the radius of the ring. Now, we will discuss the factors which affects surface tension, such as temperature. Generally, surface tension decreases as temperature increases. At higher temperatures, molecules have greater kinetic energy, reducing their attraction to each other at the surface. Next is impurities. Surface tension can increase or decrease depending on the type of concentration of impurities. Impurities disrupt the cohesive forces between liquid molecules, altering the surface tension. Surfactants, for example, can lower surface tension by absorbing at the liquid air interface. Another factor is type of liquid. Surface tension varies with the type of liquid. Different liquids exhibit different intermolecular forces. Water, for instance, has higher surface tension compared to many organic solvents due to strong hydrogen bonding. Next, presence of surfactants. Surfactants reduce surface tension. Surfactants are molecules with both hydrophilic, that is water attracting, and hydrophobic, that is water repelling parts. They absorb at the liquid surface, disrupting cohesive forces and lowering surface tension. Pressure is another factor. Surface tension is minimally affected by pressure changes in liquids. Unlike gases, where pressure significantly affects surface tension, in liquids, pressure changes have minimal impact due to the incompressibility of liquids. Next is electric field. Electric fields can alter surface tension. Electric fields can induce polarization of molecules at the surface, affecting their cohesive interaction and thus surface tension. And presence of salts. Salts can alter surface tension as well. Salts in water can ionize and change the surface chemistry, affecting the intermolecular forces, and hence surface tension decreases. Surface tension plays an important role in engineering, such as in coating and painting, ensuring uniform coating and painting surfaces. Surface tension affects how paints and coatings spread over surfaces, influencing adhesion and coverage quality. In inkjet painting, precision deposition of ink on various surfaces. Surface tension controls ink droplets formation and spreading, crucial for high resolution printing, which is very important to print any kind of material with the help of inkjet printing. In microfluidics, manipulating small volumes of liquid in microscale devices. Surface tension governs fluid behavior in microchannels, impacting flow rates, mixing and droplet formation, which is very crucial and important parameter in the field of engineering and technology. In bubble and foam formation, contributing bubble and foam generation in various processes. Surface tension determines bubble size and stability, influencing processes in food processing, pharmaceuticals and materials synthesis. In case of material synthesis, this surface tension plays very crucial role, which are nowadays very interesting. In optics and lens manufacturing, coating and cleaning of optical surfaces must be done with the help of the phenomenon based on surface tension. Surface tension affects the wetting behavior of cleaning agents and coatings, ensuring clarity and performance in lenses and optical components. these optical components can be magnified with the help of concepts based on surface tension. In surface modification and weighting, enhancing or reducing weighting or surfaces. Surface tension helps in designing surfaces with specific weighting properties of self-cleaning coatings, anti-fogging materials and adhesion enhancement in biomaterials. In detergency and cleaning, nowadays in our daily life plays very impact, on which we can say that surface tension is a crucial phenomenon, improving cleaning efficiency in detergents and industrial cleaning processes. Surfactants reduce surface tension, allowing better wetting and penetration of soils, enhancing cleaning efficacy. Cleaning efficacy is, we know well that we are regularly involving in this process in everyday life, like our colleges, schools, at home and different places like malls inside our city or multiplexes, where detergency and cleaning is very important. Next one, in fluid dynamics and heat transfer. And we know well that in fluid dynamics and heat transfer, nowadays research is going very well. So, in this field, surface tension playing a crucial role, enhancing efficiency in heat exchangers and fluid systems. Surface tension influences fluid flow dynamics such as capillary action, droplet formation, interface stability in multi-phase flows. So, we can say that surface tension in fluid dynamics and heat transfer is very important. Now, innovation and research is going on surface tension, such as advanced materials and coatings. We know well that right now we are living in the world of innovations and research, in which many parameters are being affected by the surface tension, which is directly related to us and which gives us very better quality of life with the help of innovations and research. So, first one is advanced materials and coatings. Innovation is self cleaning and anti-fogging surfaces, we know all about that, and research is developing coatings with tailored surface tension properties for applications in aerospace, automotive and consumer electronics to resist dirt and moistures. You can understand that suppose we are lacking this kind of innovation and research in this field. So, what will happen, you can understand well, because nowadays most of the research is being focused on advanced materials and coating. About coating, you know well that you are having like painted materials. Suppose you are going to rough a surface, then you find some roughness, but nowadays nano painting is available there. So, spray painting, nano painting, we are much familiar about that. Whenever this kind of painting is being used, then a fine smooth surface is observed. So, innovation and research on surface tension plays very crucial role. Next one is microfluidics and lab on chips devices. Innovation is miniaturized diagnostic and analytical platforms. How can we explain it? Like what is being research is done in this field. So, we can understand it by utilizing surface tension to manipulate small volumes of fluids in microchannels for rapid and cost effective medical diagnostics and chemical analysis. So, lab on chip device, what we can say about lab on chip devices, like chips are very small in sizes and very crucial programming and doping are there. So, we can control its process with the help of surface tension. Now, next one in drug delivery system. You know well that nowadays drug delivery system is being improved in our daily life. So, everyone is required of this kind of innovation and research. So, innovation for enhancing drug absorption and targeting. So, research for this is designing nanostructured drug carriers and formulations with controlled surface tension to optimize drug delivery efficiency and reduce side effects. We know well that nowadays, suppose we are taking any kind of drug. So, first important cause is what will be the side effect of this kind of drug. So, we must aware about the side effect of drug, and drug delivery system must be affected with the help of innovation and research in the field of surface tension. Now, next one is research and innovation in the field of biomedical engineering, innovation in biomimetic materials and medical devices, and research for integrating surface tension principles to design artificial organs, tissues and surgical implants with improved biocompatibility and functionality. Nowadays, we know well that we will have an AI based teacher in schools and colleges. So, we need multiple organs to create with the help of machines and robotics, in which welding, soldering is also a necessary component. That time we need to work on surface tension, like how to increase the efficiency of the machines we are going to assemble with the help of mechanical engineering, electronics and artificial intelligence. Now, next research and innovation is being done on energy and environment applications. Energy and environmental applications are very important nowadays, and research is being done on two portions simultaneously, like renewable energy of source, how can we create, and second one, how we can save the electricity inside our house. So, innovation in this field is also equally applicable in the oil recovery and water purification technologies, because surface tension is very crucial in this field also, we know well, and research is using surfactants and surface tension manipulations techniques to enhance efficiency in oil spill cleanup, desalination and wastewater treatment processes. In soft robotics and flexible electronics, innovation is on flexible and adaptive structures, and research is applying surface tension principles to develop soft actuators, sensors and wearable electronics gadgets that mimic biological systems and respond to environmental changes. In food science and agriculture, innovation is controlled release and encapsulation technologies, and research is harnessing surface tension to encapsulate flavors, nutrients and agrochemicals for improved stability bioavailability and targeted delivery in food and agriculture industries. In nanotechnology and nanofabrications, now I want to say that this field is very recent, which affects our daily life directly, which is nanotechnology and nanofabrications. Innovations in nanomaterials synthesis and manipulations. There are different kinds of methods through which we can prepare nanomaterials and synthesis well, with the help of some manipulations being adopted. And research is exploring surface tension effects in nanoparticles assembly, nanostructures patterning and surface modifications techniques for advanced materials and devices. Applications of surface tension in daily life are as, like we can know well that surface tension is directly related to us in our daily life. So, first one is formation of droplets. Water beads on a freshly waxed car surface or leaves. Surface tension causes water to form spherical droplets, minimizing surface area and reducing interaction with the waxy surface. Next one is capillary action. The ability of paper towels or sponges to soak up liquids. Surface tension and adhesive forces between the liquid and the fibers allow liquid to rise and spread through the material. Next one, floating objects. Small insects like water striders walking on the surface of water. In our daily life, it is also being observed that mosquitoes are floating at the top of the water. This is due to the surface tension in water. Surface tension create a skin on the water surface that can support light objects and insects, preventing them from sinking. Next one is soap bubbles. Children's blowing soap bubbles, we know well about that, and soap reduces the surface tension of water, allowing bubbles to form and stabilize, creating a thin flexible film of liquid. Next one is cleaning and detergents. Dishwashing and laundry detergents. Detergents lower the surface tension of water, making it easier for the water to spread and penetrate fabrics effectively, removing dirt and grease. Next one is cooking and food preparations. Cooking oil forming droplets on a water surface, and surface tension prevents oil and water from mixing easily, leading to the formation of distinct oil droplets. In medicine and biology, alveoli in the lungs. Surface tension helps keep the alveoli, which is air sacs in the lungs, stable, allowing for efficient gas exchange. Surfactants in the lungs reduce surface tension to prevent alveolar collapse. Insecticide sprays. Insecticide sprays spreading on water surfaces. These sprays often contain surfactants that reduce surface tension, allowing the liquid to spread more evenly and cover a large surface area. And in painting and coating, applying paint or varnish to surfaces, surface tension affects how paint spreads and adheres to the surface, influencing the quality of finish. Now we can summarizes the entire topics covered today as: surface tension is the energy required to increase a liquid surface area caused by cohesive forces among liquid molecules. Surface tension arises from cohesive forces within the liquid and adhesive forces between the liquid and other surfaces. Surface tension is measured in newtons per meter using techniques like the capillary rise method, drop wet method, Will-Melmy plate method and Du-Noye ring method. Surface tension generally decreases with increasing temperature due to increased molecular motion. Impurities can alter surface tension, while surfactants typically reduce it by disrupting cohesive forces at the liquid's surface. Surface tension is observable in everyday phenomena such as droplet formation, capillary action and the stability of soap bubbles. It is crucial in coating technology, inkjet printing, microfluidics and material science, influencing fluid behavior and material properties. Advances in surface tension research are leading to new materials, improved microfluidic device, better drug delivery systems and enhanced environmental solutions. This slide is being shown as references in which materials are studied. Thank you so much for your kind attention.